Hello, we are going to start a new chapter that is vectors. As usual, first we will go through the synopsis. Some important points. First of all, what are scalars? Scalars are quantities which has only magnitude. That means whose only length can be measured. For example, speed. For example, distance, mass, area, volume, density, time, temperature, work, power, potential, electric charge. All these are scalars which do not have direction. But vectors are quantities which have magnitude as well as direction. You can measure the length and you can measure the direction also. For example, displacement is a vector. Velocity is a vector. Force is a vector. Acceleration is a vector. Momentum is a vector. Moment of force about a point is a vector. Angular velocity is a vector. Now, a vector is represented by a directed line segment. So this is directed line segment. A line segment which has direction. Now, if a vector is starting from point A and moving to point B, it is represented as vector AB. A is called initial point and B is called terminal point. And the line AB is called line of action along which the vector moves. Magnitude of vector AB is written as like this, and its magnitude will be just length of the AB segment. Vector AB will be always equal to negative of vector BE. A vector whose initial point and terminal point is one and the same, that is called a null vector or zero vector. It is denoted by zero vector like this. And the magnitude of zero vector will be 0. A null vector has no direction because it is starting at the same point where it is ending. Next, a vector whose magnitude is 1 is called unit vector. This vector is unit vector. Unit vector is denoted by N or E. If a vector AB is given and you want unit vector along the AB vector, that is, you can get N vector by taking AB vector and dividing. One second. In order to get unit vector along the vector AB, you have to take AB vector and divide it by the magnitude of AB vector. Next, if two vectors have equal magnitude and same direction, they are called equal vectors. So AB vector is equal to PQ vector. You can compare and say like this. So one more thing I want to say, if AB vector is equal to PQ vector, magnitude of AB vector will be equal to magnitude of PQ vector and AB will be parallel to PQ. The next is, if AB is a vector, the negative of the vector, we can have negative of the vector, and that will be negative AB. So BA vector is nothing but negative of AB vector. And so AB vector plus BA vector can be taken as 0 vector. If two or more vectors lie on the same line, they are called collinear vectors. So if A vector and B vector are collinear vectors, then we can say that A vector is multiple of B vector, or B vector is multiple of A vector, where K is some number. And then we can say vector A and vector B are linearly dependent. Vectors which are not collinear, they are called non-collinear vectors. Similarly, if vectors lie on the same plane, if there are vectors on the same plane, like there is a plane, and if we have some vectors on the same plane, they are called coplanar vectors. Next is free vector. What is free vector? A vector which can be shifted along its line of action or parallel to itself, and whose initial point can be chosen anywhere, is called free vector. Like suppose if there is a vector, it is like this. If I will shift this vector here, or if I shift it here, such a vector is called free vector. Its magnitude will not change, its direction will not change, but the vector can be shifted to any position as we like. Similarly, we have localized vector, a vector which can be shifted only along its line of action is called localized vector. Like if there is a line of action and if there is a vector from here to here, it can be shifted only along its line of action. Such a vector is called localized vector. That is the difference between free vector and localized vector. Now, bound vector means a vector whose initial point is given fixed point so that the vector remains in the fixed position only. Like suppose if I say the fixed point is origin. So if the vector remains like this only, it cannot be moved anywhere. Its initial point is fixed. Such a vector is called bound vector. If from the same initial point many vectors come out, they are called co-initial vectors. Next is like vectors. The vectors are said to be like vectors when they have same direction irrespective of the magnitude. So the magnitude can be different, but the directions are same. Such vectors are called like vectors. Position vectors. If we take origin and we fix the vector at the origin, that means origin is the fixed point and P be any vector in the O is a fixed point, P be any point in the space. Then OP is called position vector. It is denoted by R. The next is triangle law of addition of vectors. Addition of vectors. Suppose there is a vector like this. This is vector A and it is named as AB here. And then there is another vector BC. It is named as vector B. So AC vector is called vector A plus vector B. This is called triangle law of addition of vectors. But you have to remember AC vector is AB vector plus BC vector. But magnitude of AC vector is not same as magnitude of AB vector plus magnitude of BC vector. And another point here to be noted down is if you take AB vector, BC vector and CA vector, it will be equal to 0 vector. Apart from triangle law, there is parallelogram law of addition of vectors. What is this parallelogram law of addition of vectors? Suppose if you have vector AB given as vector A and vector BC given as vector B, then AC is vector A plus vector B. In other words, you can add this in another way. You can take BC vector, but here it is named as AD. So it is B vector only. And then you have DC vector, but it is vector A. So you can write AC vector as vector B plus vector A also. That means vector A plus vector B will be same as vector B plus vector A. This is called parallelogram law of addition of vectors. And we can also say addition is commutative. Addition is commutative in vectors. Similarly, Addition is associative also. A plus B vector plus C vector is same as A vector plus B plus C vector. That means addition is associative in vectors. Then in vectors, there is an additive identity. That is, the zero vector is the additive identity. Like in numbers, we have. Not only that, there is additive inverse also. For A vector, negative A vector is additive inverse because it leads to 0 here. So negative minus of vector A is called additive inverse of vector A. Suppose if you want to express a vector AB, imagine this is vector AB. You want to express it in terms of its position vector. We will take origin as fixed point. The position vector of point A is vector A and position vector of point B is vector B. OA, OB. So how we can write is vector OA plus vector AB is equal to vector OB. Or AB vector can be written as OB vector minus OA vector, or vector B minus vector A. Any vector AB can be written like this. You have to remember the order of the letters. Subtraction of letters vectors means if you have A vector minus B vector, it is nothing but adding up of A vector and negative of B vector. Scalar multiplication in case of vectors is, suppose there is a vector A. If you are multiplying with 2, then this becomes 2A vector. So a scalar is multiplied to a vector. Similarly, if you half it, this is the vector you get it. It is half of A vector. So this is called scalar multiplication of vectors. Scalar multiplication means a number is multiplied to a vector. So this property, we can use it like this. If A and B are collinear vectors, then we can write vector A equal to K into vector B. Similarly, there are some more properties in vectors. That is, m plus n is a scalar. If you multiply to vector A, it is same as m into vector A plus n into vector A. M into vector A plus B is equal to m into vector A plus m into vector B. And then mn into vector A is same as m into NA vector plus n into MA vector. This is m plus n, not mn. This is how you can write. Now in vectors, magnitude of vector A plus vector B is less than or equal to magnitude of vector A plus magnitude of vector B. Whereas magnitude of vector A minus B is greater than or equal to magnitude of vector A minus magnitude of vector B. The next thing is We have section formula in vectors also. That is, there is a vector AB. Position vectors are taken. Position vectors of A is vector OA, and position vector of B is vector OB. Now suppose if there is a point P which divides AB in the ratio m is to n, then position vector of the point P, that is OP vector, is m into B vector plus n into A vector by m plus n. If the division is interior, if the division is exterior, then OP will be m into B vector minus n into A vector by m minus n. The same theory, if AB is the vector and P is the midpoint, P is the midpoint, then the position vector of the midpoint is A vector plus B vector by 2. Similarly, the centroid of triangle ABC is vector A plus vector B plus vector C by 3. That's the centroid of triangle ABC, where the position vector of A is A, position vector of B is B, and position vector of C is C. Similarly, centroid of a tetrahedron. Suppose there is a tetrahedron like this. I'll draw it here. This is a tetrahedron. So in tetrahedron also there is a centroid, and centroid of tetrahedron is given as vector A plus vector B plus vector C plus vector D by 4, where A is the position vector of point A, B is the position vector of point B, C is the position vector of point C, and D is the position vector of point D. Based on that formula. Similarly, in a triangle ABC, if position vector of A is A, position vector of B is B, and position vector of C is C, the in center, it is given as A into vector A plus B into vector B plus C into vector C by A plus B plus C. The next formula is, if there is a triangle A with position vector A, B with position vector B, C with position vector C, then we can find orthogonal or orthocenter. Instead of taking orthogonals, directly I will take orthocenter of this triangle is given as vector A into tan A plus vector B into tan B plus vector C into tan C by vector A plus vector B plus vector C, or it can be taken as in denominator, you can take tan A plus tan B plus tan C. Next is if A and B are non-collinear vectors, then linear combination of vectors A and B is x into vector A plus y into vector B. This is how you write linear combination. If x into vector A plus y into vector B is 0, then I can say x and y both will be equal to 0. But if x and y are not equal to 0, then I can say A and B are collinear vectors. Either one of them should be happening. Next, you can say two vectors are coplanar. About coplanar vectors. If they lie on same plane or parallel planes anywhere. If A, B, C are coplanar and linearly dependent, then you can say x into vector A plus y into vector B plus z into vector C will be equal to 0 vector. Otherwise, if vector A, vector B, vector C are non-coplanar and still x into vector A, y into vector B plus z into vector C equal to 0, then we can say x, y, z equal to 0. So using this about coplanar linearly dependent or collinear linearly dependent, we can say that vector R is equal to XA plus YB under some conditions. That is, vector A and vector B are non-zero and non-collinear. That is one condition. And the next is R is coplanar. The vector R is coplanar with vector A and vector B. Similarly, I can write R vector equal to x into vector A plus y into vector B plus z into vector C under some condition. That is vector A, B, C should be non-zero and non-coplanar vectors. And then R has to be coplanar. R is the linear combination. That is, I can say that XA plus YB plus ZC are vector components. I can say in this way of vector R in the direction of vector A, vector B, and vector C. If I, J, K are three mutually perpendicular unit vectors, then any vector R can be written as x into I plus y into j plus z into k. And it is also written as in the form of xyz. Now, how can you show that vectors are collinear or 3 points are collinear? There is a test. 3 points are collinear. How can you say? There is a test for that. For example, the 3 points are A, B, C. So these are 3 points. And A, B, C are position vectors of these 3 points. So I can say they are collinear if vector AC equal to K times vector AB. If there is no such K, then the vectors are non-collinear. This is how you can see. Otherwise, there is one more test also. 3 points are ABC with the same position vectors. If we can find three scalars such that x into vector A plus y into vector B plus z into vector C is equal to 0, where x plus y plus z is equal to 0, then also we can say that the 3 points are collinear. The next is dot product of the vectors, that is A dot B. It is defined as AB into cos theta, or magnitude of vector A into magnitude of vector B into cos theta. So from this, we have a formula for cos theta, which is A dot B by magnitude of vector A into magnitude of vector B. This will be helpful to find angle theta. So if A dot B equal to 0, then either A will be 0 or B will be 0. Suppose if A is not 0, B is not 0, but still A dot B equal to 0. That implies A will be perpendicular to B. Or cosine theta will be 0. That means theta will be pi by 2. If A and B are like vectors, then A dot B will be equal to magnitude of vector A into magnitude of vector B. That is, it will be equal to AB. Similarly, there are many points regarding the dot product. If A and B are unlike vectors, not like vectors, then A dot B will be equal to minus of magnitude of vector A into magnitude of vector B, that is minus B, minus AB. So theta will be 180 degrees, or cos theta will be equal to -1. Dot product is commutative. That means A dot B will be equal to B dot A. Similarly, it is following distributive property also. That is A dot B plus C will be equal to A dot B plus A dot C. The next is, if you want A dot A, you can write it as A into A into cos 0 degrees, that is A square. That means magnitude of vector A square will be A dot A. That is, magnitude of vector A will be square root of A dot A. Now, if there is a vector A, its projection on vector B is this. This is the projection of vector A on vector B. This is vector B. And that is A dot B by magnitude of vector B. Similarly, if this is vector B and you are taking the projection on vector A, that means from here to here, projection of vector B in the direction of vector A, I can see. And that will be equal to B dot A by vector A. Now suppose if vector A is A1I plus A2J plus A3K, and vector B is B1I plus B2J plus B3K. Then A dot B will be equal to A1 B1 plus A2 B2 plus A3 B3. Implies AB cos theta will be equal to A1 B1 plus A2 B2 plus A3 B3, or cos theta will be equal to A1 B1 plus A2 B2. These are not powers. They are A2 B2 A3 B2. A2 B2 plus A3 B3 by AB. Like this we can find. Magnitude of vector A can be given as root of A1 square plus A2 square plus A3 square. And magnitude of vector B is given as root of B1 square plus B2 square plus B3 square. That's why we know that cos theta equal to A dot B by mod of A into mod of B. So this can be written as A1 B1 plus A2 B2 plus A3 B3 by root of A1 square plus A2 square plus A3 square into root of B1 square plus B2 square plus B3 square. This is also another formula for finding cos theta, the angle formula. Then I cross j, this I will tell later, but first I will tell you easy formula. There is one formula. I dot I is equal to j dot j equal to k dot k equal to 1. That means I square equal to j square equal to k square will be equal to 1. Whereas I dot j equal to j dot k equal to k dot I equal to 0. The next point you have to remember is magnitude of a plus b will be equal to magnitude of a minus b if and only if a is perpendicular to b, where a is not equal to 0, vector b is not equal to 0. Then magnitude of vector a dot b is less than or equal to magnitude of vector a into magnitude of vector b. The next is, in some questions, you will be asked to find the components of vector r in the direction of vector a. Then it will be equal to r vector dot a by magnitude of vector a square into vector a. And sometimes you will be asked to find components of vector r perpendicular to vector a. Then it will be r minus r dot a by mod of a whole square into vector a. Then we have right-handed system of vectors. IJK are also in right-handed system. Coming to vector product. For vector product also, we have some properties, we have some definitions, and we have some usage of it. First of all, the two vectors A cross B, that is vector product, and it is defined as magnitude of A into magnitude of B into sine theta into a unit vector n, where theta will be between 0 and pi. It can be equal to 0 and pi also. What is this unit vector n? Unit vector n this is a unit vector first of all. I want to mention it. And moreover, this unit vector n will be perpendicular to both vector A and vector B. And remember, vector A, vector B, vector n will be in right-handed system. Remember, A cross B is vector, whereas A dot B is a scalar. Magnitude of vector A cross B can be written as magnitude of A into magnitude of B into sine theta. Again, some more properties, as I said. A cross B will be equal to minus B cross A. But magnitude of A cross B will be same as magnitude of B cross A. Vector product is not commutative. That means A cross B, this cross product especially, is not equal to B cross A. Then to find angle between the vectors, you can use even sine theta equal to mod of A cross B by magnitude of vector A into magnitude of vector B. Then sometimes if you are asked to find unit vector perpendicular to A dot B, it is A cross B by magnitude of A cross B. Like this also you can find. For example, I will ask you find unit vector perpendicular to 2i minus j plus k and 3i plus 4j minus k. If this is the question. So what you have to do is you have to take cross product of 2i minus j plus k and 3i plus 4j minus k. And then by magnitude of 2i minus j plus k cross 3i plus 4j minus k. And for cross product, you have to take determinant. For the numerator, if I want to find the cross product of the numerator. So what I will do is I will take the determinant ijk and I'll write 2 minus 1, 1 the coefficients, 3, 4 minus 1 the coefficients. I will be multiplied with, I will write directly, I'll skip one step and write. That is, the vector I will be multiplied with 1 minus 4, that is minus 3. Then the vector minus j will be multiplied with minus 2 minus 3 minus 5. So plus 5. And then vector k will be multiplied with 8 plus 3, that is 11. And then magnitude of this minus 3i plus 5j plus 11k can be written as root of 9 plus 25 plus 121. That is root of 155. Therefore, the unit vector which we were talking about can be written as minus 3i plus 5j plus 11k by square root of 155. There are many more points to be discussed. As much as possible, we will discuss in this class only, because in next class we will not have time to discuss about the synopsis. Next, we have collinearity test of two vectors. Collinearity test of two vectors here also. Like suppose if two vectors A and B are collinear or parallel, anything can happen. Then the test is A cross B must be equal to 0 vector. Next is A cross A is 0 vector. I cross I or J cross J or K cross K all are 0 vectors. Whereas I cross J is equal to K, J cross K is I, and K cross I equal to J. But this order if it is reversed, that is, if we have j cross I, it will be minus k. If we have k cross j, it will be minus I. If we have I cross k, it will be minus j. In the next page, suppose if we have vector A as a1i plus a2j plus a3k, and vector B as b1i plus b2j plus b3k. I can say vector A will be equal to vector B if A1 equal to B1, A2 equal to B2, and A3 equal to B3. And I can say A will be parallel to B if A1 by B1 equal to A2 by B2 equal to A3 by B3. And then A cross B, if I want to find, I have to find the determinant of ijk, A1, A2, A3, B1, B2, B3, which I have shown you already in an example. So you have to find determinant of this. Next is finding vector area. If normally in geometry, if the area is A and N is unit vector perpendicular to the plane whose area we are finding, then the vector area will be nothing but A into this unit vector. And magnitude of A into this unit vector is just A. So now we will find areas of many figures, vector areas. Like if you have triangle ABC, the position vector of A is A, B is B, and C is C. Then I'm finding vector areas here. So I will not mention again and again. So the vector area here will be of triangle ABC will be half into A cross B plus B cross C plus C cross A. Or I can write half into vector AB cross vector AC, or half into vector BC cross BA, or half into vector CA cross CB. Anything. Similarly, for a parallelogram, suppose there is a parallelogram OA CB. This vector is vector A, OA vector is vector A, and OB vector is vector B. Then vector area of the parallelogram will be A cross B. Of course, if you take mod of A cross B, you will get normal area. Similarly, if there is a parallelogram ABCD, the diagonal AC is represented by vector A and the diagonal BD is represented by vector B, then area of the parallelogram will be as I'm taking vector area. I will not take mod. So area of the parallelogram, vector area especially, will be half into A cross B, or half into AC vector cross BD vector. For example, suppose A is 3i minus k. Vector B is I plus 2j. These are adjacent sides of a parallelogram. Then its area, not vector area, just area, will be mod of A cross B. That means first we have to find A cross B. So first we will find A cross B. That is, I will take ijk. I will take 3, 0, minus 1, 1, 2, 0. So it will be I is multiplied to 2 minus j is multiplied to 1. That means simply j I will have. And then k is multiplied to 6. This is the vector AB. Then mod of vector A cross B will be square root of 4 plus 1 plus 36. That is square root of 41. So I can write just the area, not vector area. It is just area. It will be square root of 41. This is just an example. One more example I'll give you. For example, vector A is 3i plus j minus 2k. Vector B is I minus 3j plus 4k. And these are diagonals of a parallelogram. Then if I want just area, not vector area, it will be 1 by 2 into mod of A cross B. So first I have to find what is A cross B. So I will find A cross B, that is determinant of ijk, 3, 1, minus 2, 1, minus 3, 4. So that means I is multiplied with 4 minus 6 minus 2, minus j is multiplied with 12 plus 2, that is 14, and k is multiplied with minus 9 minus 1, minus 10. And then when I take mod of A cross B, it will be square root of 4 plus 196 plus 100. And that is square root of 300 or 10 root 3. So which I will write it here. The place where I am writing 10 root 3 by 2, or the area is just 5 root 3. There is a relation between cross product and dot product. That is A cross B whole square plus A dot B whole square equal to A square B square. I think we could do synopsis only till here. Remaining is just application of vectors in physics, and some scalar triple products are also there. About scalar triple products we will do in the next class before doing some problems. With this we will end the session.